Hello. Welcome. Whoa, there we go. Thank you for joining us here at Coalesce today. My name is Jillian Corkin, and I lead the community advocacy team at DBT Labs. I will be your host for today's session, The Return on Analytics Engineering. And it is an honor and a pleasure to introduce to you David Jayatillake, who is the head of data at Metaplane, amongst numerous other data endeavors. You are in for a treat today, as David is here to talk about the true value that analytics engineering brings to organizations that make the investment. This is one of those talks to share with your leadership team to help them get it. Before we jump in, here are some recommendations for those that are tuning in online for making the best out of this session. All chat conversations are taking place in Coalesce, the Return On channel of the DBT Slack. Everyone say hi to Ian. He's our chat champion, holding it down. And we encourage you to ask questions to other attendees, make comments, or react at any point in the channel. After the talk, David will drop in and answer any questions. Okay, that is enough from me. Everyone, please give it up for David. Come on up, David.
Thanks for coming to my talk, and I hope you're having a great time in New Orleans and the first in-person Coalesce. So a bit about me. I'm David. I'm head of data at Metaplane. I've been a DBT community member for about just over 3 years now, which means apparently that means I'm old school. And I wanted to do a talk to give back to the community. Last year I was on a panel, and this felt like kind of like a natural progression, but I didn't really know what I wanted to talk about. So I ended up talking to Anna, who's leads community here at DBT Labs, about what would be helpful to talk about for the community. And she said, something we're hearing from the community is that, how do I know I'm doing data modeling or analytics engineering well? And my immediate thought was, you know you're doing it well when you're having the impact and feeling the benefits of the discipline. And this is how I came to the title, The Return on Analytics Engineering. So what is analytics engineering? So a couple of quotes. Funnily enough, we've got some ThoughtSpot people in the house. But yeah, the first one's from ThoughtSpot, and it's quite comprehensive about what they feel analytics engineering is. And the second one from DBT, analytics engineers provide clean data sets to end users, modeling data in a way that empowers end users to answer their own questions. So what I would say analytics engineering is, it's the process of enabling data to be consumed safely by users and/or processes. And I feel this is distinct from the data engineering discipline where pipelines are built. This is actually from the leg where raw data is easily accessible already, and it's to be used for building business data sets or to be used elsewhere. So why? Why should we do analytics engineering? Surely we should be expecting some benefits. So I believe there are great benefits to it, and I've experienced these benefits, and I've grouped them into 3 themes. So collaboration, quality, and value. And I'm aiming to explain to organizations new to the discipline, those who are a bit further down the line, what the impact of these different aspects are and what value this generates for an organization. And I think it's pretty clear why we want to explain this to a company that's new or considering using analytics engineering inside their organization. But I think it's also the case that many organizations that already have analytics engineering disciplines may have lost sight of what they're trying to achieve at a high level. And sometimes, I've seen many teams which start out with 1 or 2 analytics engineers in a scrappy way, just trying to deliver exactly what they need at the time, just the basics, and they haven't even necessarily considered some of these higher level objectives, which are really valuable. And to be honest, and I think many of us will have experienced this, data teams are often put in cost centers. We're not often the best funded teams. And then even with models like hub and spoke, analytics engineers are often inside the hub, which is a cost center, usually. So analytics engineers can still spend their time firefighting, despite the efficiencies gained from the discipline. So collaboration. readability and navigation. So previous to analytics engineering, and this is how I started my career, all data modeling was done on something like SQL Server or Oracle using stored procedures. And these stored procedures, they don't have any inherent lineage. There's no modularity to it either. So new joiners would take a long time, and I've been in this position, reading a 10,000-line stored procedure, trying to break it apart, figure out how it works, and which bits are needed, which bits actually do anything useful. And it would just mean it would take a very long time for a new joiner to actually be productive. And I think this is one of the key distinctions between analytics engineering and BI development as disciplines. Analytics engineers build modular, easily readable, discoverable models with clear lineage. And fundamentally, this allows new joiners to become productive faster and for everyone in the org to understand the provenance of their data more easily. And previous to this, in those stored procedures, they would be black boxes. No stakeholder would ever understand how their data was put together. And it becomes a multiplayer game. So when analytics engineering is implemented well, and it's distributed to other teams beyond the main data team, you'll find that your core contributors are analytics engineers, but you have a long tail of contributors who are actually larger in number. And I've borrowed this contributor screen from the Lightdash repo. I've got some Lightdash folks in the house. And it enables models like data mesh to happen in an organization. Software engineers and other teams can look after their data from source to presentation. And teams which need to operate independently can do so, but they can also do it in a framework that other people in the organization can benefit from. And this allows for a single source of truth. Different teams can collaborate on the same data without duplicating that data. Business continuity. It's like a typical English phrase. It's like, what happens if you got hit by a bus? That's business continuity. So everything that's in production should be in your main branch and Git for its respective project. So that means anyone can pick up the stack, and they know what's in production. If they know the tooling, understand the framework, they can pick it up and start working and fix any problems. And this was not true before. People used to have scripts stored on their laptop, probably on their desktop screen, and they'd run them, and then they'd make a final version, and a final version, and a V7, and a mess. And then I think also the structure of how you can build a project in dbt also facilitates this business continuity, and that it just becomes much more easy to find out what's going on. I also think that as part of implementing analytics engineering, you start to bring in some agile principles. I'm not talking about delivering all of agile, because nobody ever delivers all of agile, but some of the principles about having a process of knowing what is being worked on, what has been finished, what is to be done. And these processes can be overridden, but there is a process, and it minimizes context switching, maximizes the benefits you're getting from your analytics engineers. And I think this kind of part of a product mindset is what helps to deliver business continuity through performing needed work in the right order. And I feel like that's been baked into the analytics engineering discipline. So what's gold and what's not? So when I say gold data, what I mean by that is this is the most important data your company has. It's the kind of data that you have spoken or possibly unspoken SLAs on. And this is the data that, if you see a run failure on Saturday, you fix that on Sunday. You don't want anyone looking at this data if it's broken. And I've been there before. Has anyone run a dbt cloud job off their phone from their bed before? Yeah, I've done that. So gold data should be small. I think this is one of the things that makes it doable, is that what is this data that your organization really depends on. And it's a small fraction of your whole overall data. And you're pretty ruthless about pruning anything that shouldn't be in there, merging things which are similar, so that you just make it manageable and reliable. And this is the data your companies run on. It's not an experimental data source. It doesn't need to change often or fast. It should change as your company changes overall strategy. And analytics engineers are able to keep this data and its pipelines stable and reliable. And this allows the data team and other contributors to go at two speeds: slow and process-driven for gold data, and fast and loose with experimental data. And I think this is like one of the ways that many teams struggle, is that they try and do one or the other. And you need to go at both speeds depending on the context. And analytics engineering, I feel, really enables that by having this segregation of what's gold and what's not. And your org should not want to accept non-gold data, right? You should be able to push back on stakeholders who are trying to introduce non-gold data into decision-making. When they want to introduce that amplitude chart into an investor deck, you should be able to say, no, I'm not having that, right? And what does this give us? Trust is preserved, right? So it's probably the data team's most precious asset, trust. And you can preserve it without holding back other teams from experimenting. So increased development speed and output. There are elements of the software engineering workflow that has been incorporated into analytics engineering. And these really help with quick development. And these are things like version control, CI/CD. And these provide safety that wasn't present in working with data before. Before this, when we changed a stored procedure, we'd change it, try and run it, broke, messed up the production data, fix it, run again. And this is how we do development. It wasn't great. And it made you cautious. You didn't want to make too many changes too quickly because you just couldn't guarantee any quality in your output. So because of these facilities to enable quality, you can have a higher output because the level of complexity you're able to handle is deeper, and it's just much more possible to develop quickly. So things that were difficult before, things like state change analysis, lifetime value, funnel conversion, these things become doable or even easy when they were very difficult before. And I think what it also allows is for small teams with the analytics engineering discipline to do more than those without. And I've been in that position before where I've been a team of two and we delivered some of these projects which we just wouldn't have had a hope of before. Quality. So one of the problems, I think, in the old world as well, and this also goes into the big data world, is you used to have these silos of data, often doing the same thing with maybe 2 steps to the left. And when these things are defined in multiple places, it's very hard to understand dependencies and what things will break unintentionally in development. And people used to build far too much. You've probably seen me post on this. People used to do a lot in things like Looker and even in other tools, which you shouldn't be doing in a BI tool. BI tool should be there for minor transformations, presentation, groupings. And this allows for business logic to be found and changed. This is essential to have a single source of truth. So dryness, do not repeat yourself. That's what dryness means. And why should you not? Because it's not only because it's faster, but it also ensures consistency. This allows you to change business logic globally, easily, because it's defined once to use everywhere. If the same logic is defined in multiple places, it makes it really difficult to guarantee quality in development. When this is done, you have greater confidence in the changes you'll make, and fewer bugs as a result, leading to higher quality. Tested and observed, right? So I think we didn't used to have even any principles of testing before in BI development. Unless you built custom SQL scripts to run your tests, you didn't have testing as a first-class citizen. So I think tests are great, and you're probably familiar with DBT tests, and I really love using them for checking for Boolean outcomes. So for example, this column should be unique, or this column should never be null, or for testing things like referential integrity between models. But I also believe observability should be implemented. And it's great for monitoring scalar trends. This is where it's very difficult to write a yes-no test for. This is where it's a trend that can fluctuate with seasonality, with long-term growth trends. And I think this allows for balance in your quality approach. Testing for every eventuality is just not scalable. Once you have thousands of tests in your test suite, it's a very expensive part of development. So it's better to test when you know what should happen, and where you don't, you should observe with anomaly detection to protect yourself. And what do we get from this? Trust in the data team is preserved as issues are prevented or dealt with earlier. And so data shame, what's data shame? So data shame, and I think many of you have felt this feeling, is when a stakeholder slacks you or something, says, oh, I think there's something wrong with your data, and you didn't even know, and you have this sinking feeling. Do you know that sinking feeling? That's data shame, okay? I felt it lots of times. Incident management, okay? With the best will in the world, doing all these things will still go wrong. And you don't need to feel flustered about it. You don't need to worry about, oh, should we try and fix it before you tell anyone? No, you just tell everyone as soon as it's happened, and you deal with it like a software outage. And this atmosphere of calm allows less experienced members of your team to learn faster without fear of failure. You can always roll back and rerun. And it's an opportunity to learn and improve from each incident. And this is based on a foundation of data usually being of a high quality and stakeholders having a high regard for it. And so while there isn't blame in the incident management process, there'll still be pain because your team is trusted by your organization, and therefore you have trust to erode. And this is a good motivator to use these incidents to learn and improve and take things to a higher level. So gold depends on gold. So I'm referring back to my definition of gold. So gold data should only depend on other gold data. It should never depend on some experimental source, typical ones like a marketing Google sheet that's somehow entered into your data. Like, your gold data should not depend on that. You should understand its provenance from application to tracking to transformation to metrics and even to decisions. And this lineage is well understood, it's governed, each step has SLAs and owners, and they're understood. So on to value. Safety, probably the biggest thing that you get from this. Stakeholders feel safe to use the data without needing to double check everything with the data team, or worse yet, other teams. How many of you experienced your stakeholder, I'm going to go and ask this engineer over here to run a query against the production database just to check that you're right. How undermining is that? So that shouldn't be happening. They trust that they would be told if there are incidents. Almost a bit naively, they just believe that they'll be told if something's broken. And it shouldn't be the case that they're saying they don't know what data to trust or what to use, or they think it's consistently wrong. That's one of the goals of analytics engineering is to avoid that. And it's, proactively, the goal of analytics engineering is to provide the safety and clarity in data and how it relates to your organization. Decisions made. So not every decision should be data-driven, right? Especially if there isn't sufficient data or relevant data. But you can still point to decisions being made with data. And you know which business processes are enabled by self-service and which data has been operationalized. You don't have a team or even team members who are just data monkeys, who just pull data without knowing what it's for. I've been a data monkey before. It's not fun. And analysts instead are focusing on deeper problems because you've enabled them to not have to run around just pulling data for people. They're doing things like deeper prototyping in tools like Hex, Count, Deep Notes, Mode, to answer the deeper questions that can't be enabled by self-service. And this is based on the clean data models that they have been provided by analytics engineers. Super stakeholders, so I've had a few of these. So they're pretty adventurous and empowered, and they really enjoy the benefits of your work. And they're trying to do advanced analysis on their own because you've enabled this through your data models. Things like LTV and cohort analysis, state change analysis. Because your data models are sufficiently capable and clear, they're able to do these things on their own. And so some of these stakeholders, they've been around for a while in your organization. They remember the bad old days. They remember what it was like before analytics engineering was there and data was always out or it was broken or was unclear. And they become so empowered that they think of novel use cases. They're not worried about business as usual. That's not what they're talking to you about. They're coming to you and saying, oh, I want to do this thing. And then it's a case of you saying, is this actually possible? OK, it's possible. This is how much it's going to cost. It's much more of like a product mindset. And finally, proactivity. You should have spare time to innovate, to retrain, to experiment with new approaches and tools. When you make your infrastructure better, you can then deliver more and then have sufficient time to innovate and make your infrastructure better and so on. You get a nice flywheel effect from this. And you should be improving things like functions and project structure and improving developer experience for new people joining and for existing members of the team so that they can still be more productive. You know why you're working on things. You're in tune with the business, so you start instinctively planning work that will be needed. You're not waiting to be asked by the product manager, oh, implement analysis for me on this thing, and oh, did you implement tracking? No. You're there at the start. You're saying, well, you want to implement this feature, you need to build this event, and this event needs to have these properties, and there's a whole theme in data Twitter and Substacks around data contracts, and this is part of that. And you're talking with those product managers about what they need to implement with their features, from the get-go and throughout that life cycle process, and when they're changing as well. And you can deliver the big OKRs related to your discipline, and you can deliver some of the rest. You're not running around feeling stressed and undervalued and just not knowing why you're working on what you're working on. But at the same time, you can lose this state because of unexpected events, because some pressure came on you and your team. But you can return to it. The implementation of the analytics engineering discipline has built in a level of resilience that you didn't have before. And I just want to say, I have achieved most of these things at different times, but very rarely have I achieved many of them at the same time. We're all human, we have limited focus and time, but we have lofty goals, aim for perfection, settle for excellence. That's kind of like the game. So thank you. That was my talk, and I have time for questions.
So I think because we actually got started a few minutes late, we're going to take questions in the Slack.
OK.
All right, everyone, thank you so much.
You can come and ask me afterwards as well.
Yeah. Or follow up with David. You stick around here next for our favorite, I'm going to get out of this light. Everyone's favorite topic, is Kimball still relevant? So Josh Devlin and Sydney Burns will be up next in this room, or you can check out one of the other rooms as well. Thank you, David.